Hey guys, Mr. Wilson here. Today we're going to look at elimination notes. At the end of this video, you should be able to solve a system of equations using elimination. Okay, the elimination method is the third and final method for solving a system of equations. What you do, is you add the equations together to temporarily get rid of one of the variables. Okay, that's simply as put. Okay, to do this, the coefficients in front of the variables you are eliminating must be the same number with opposite signs. Okay, and so as we look here, we have 5x plus 3y equals 23 and x minus 3y equals 11. Which form are both of these equations in? They're both in standard form, right? And we can tell they're in standard form because x and y are on the same side. What are the coefficients for each of these variables? Well, we have 5 by x, 3 by y, 1 by x, and negative 3 by y. Okay. Which variable are we eliminating? So as you look at this problem, remember we say we want the same number with opposite signs. When we look at the x's, we have 5 and 1. When we look at the y's, we have 3 and negative 3. So we have the same number, opposite signs here. We're eliminating y, or k, because they have the same number and opposite signs. So let's solve the system. Here's how it works. When we have the same number and opposite signs, we are able to add these two equations together. And when we add these equations together, 5x plus 1x gives us 6x. 3y minus 3y cancels out, 0 or 0y. 23 plus 1, 24. So 6x equals 24. Divide by 6, x equals 4. Once I know x, this should be just like substitution. Plug it back into one of the equations and find y. Doesn't matter which one. Okay, I'm going to plug it into the top equation just because that's the one I choose. And so now I'm going to rewrite this instead of 5x plus 3y. I'm going to say 5 times 4 plus 3y equals 23. 5 times 4 is 20. Subtract 20 from both sides. 3y equals 3. Divide by 3. Y equals 1. And so now my solution is I'll write it as an ordered pair, 4, 1. All right, number 2, solve the system using elimination. So as we look, we have 6x minus 5y equals 27 and negative 6x minus 5y equals 3. So we're looking to have our variables have the same coefficient with different signs, or opposite signs. And so we look at and see that we have that with the x's, right? This is 6x and negative 6x. So as we combine our like terms then, 6 and negative 6, they add that together, gives us 0, cancels out. Negative 5 minus 5 gives us negative 10y. 27 plus 3, 30. Divide by negative 10, divide by negative 10, boop, y equals negative 3. So now we know that y is negative 3. I'm going to plug that into one of the equations. I'll choose the top one just because that's the one I want to. You can choose either one. That's 27. Okay, so negative 5, negative 3 is 15. So 6x plus 15 equals 27. Subtract 15 from both sides. 6x equals 12. Divide by 6, x equals 2. Okay, and so now I have my x value and my y value. I'm going to write that as an ordered pair, 2, negative 3. Okay, what if the coefficients aren't the same? Aren't? Okay, the same. We can multiply one or both of the equations by a number to make the coefficients match up. So let's look at that in some examples here. We have 3x plus 2y equals 16 and negative 9x plus 5y equals 40. So different from the problems that we've seen so far, there are no numbers that just have the same and opposite, or same coefficients with opposite signs. So we have to say, okay, which number or which variable, x's or y's, would be easier to get the numbers to have the same number with opposite signs. So 3 and -9, or 2 and 5. And that's not really a right answer, because there's ways to multiply it so that they both are, so that either one works out. But when I look at this problem, I notice, hey, this is 3 and this is -9. I can multiply this top equation by 3 and I get the x's to be the same with opposite signs. So that's what I'm going to do. And when I do that, I need to make sure that I distribute this 3 to all the terms, not just the one that I'm trying to get to be the same sign, or the same number. So I have 9x plus 6y equals 48. So combining here, adding all my stuff, -9 and 9 cancels out. 5y and 6y gives me 11y. 40 plus 48 equals 88. So 11y equals 88. Divide by 11, y equals 8. Okay. Now that y equals 8, I can plug it into either one of the equations. I'm going to choose the top one and say 3x plus 2 times 8 equals 16. Okay. 2 times 8 is 16. 3x plus 16 equals 16, or 3x equals 0. And x equals 0. So my solution should be x is 0, y is 8. Plug that in, make sure that works for the second one, and it does for the second one too, right? -9 times 0 plus 5 times 8 equals 40, and that is true. 0 plus 40 equals 40. Boom. So works out. All right, second problem here. We've got 10x minus 3y equals 8 and 4x minus 3y equals 14. So as we look and say, okay, they don't have the same number and opposite signs, neither one of them, but which ones would be closest to getting that? And so what I noticed is that, hey, these are really close. The y's are just both -3y. We don't want them to both be -3y. And so what we could do is change one of them. Okay, and this is how I'm going to change it. I'd really like this one to be a positive 3y. And so that means I can multiply both sides by -1. Or sorry, this equation by -1. And so I'd have 10x minus 3y equals 8 here. And then I have -4x plus 3y equals -14. Again, it's important that I distribute that to each term. So now I combine my terms, or add these together. 10x minus 4x gives me 6x. -3y plus 3y cancels out. 8 minus 14 is -6. So 6x equals -6. 5 by 6. And I find that x equals -1. So now that I know that x is -1, I'm going to plug that into either of the equations and solve for y. So I'm going to plug it into the second equation, just because I'm choosing to. Okay, and then 4 times -1 is -4, minus 3y equals 14. I have to add 4 to both sides, so I have -3y equals 18. Divide by -3, and y equals -6. So my solution should be -1, -6. All right, number 3. Okay, we have 7x plus 5y equals 4, and 2x plus 3y equals 9. Okay, so really it's up to you on which numbers you think will eliminate faster. As I look, I think I'm going to try to get the y's to eliminate. Okay, as I look at 5 and 3, I know they both can get to 15. Okay, so what I'm going to do is I'm going to multiply this top equation by 3 to get it to be positive 15, and this bottom equation by -5 to get it to -15y. Okay, and so I'm going to do that. 21x plus 15y equals 12. And here I have -10x minus 15y equals -45. All right, so all these terms together. And now notice, and this is the important part, I have positive 15y and -15y. So when I add these together, they should cancel out. So I have 11x gone, and this will be negative 33. Divide by 11, and I find that x is negative 3. Okay, so x is negative 3. I can use that in either of these equations. I'll choose the second one. 2 times negative 3 plus 3y equals 9. That's negative 6 plus 3y equals 9. Add 6 to both sides. 3y equals 15. Divide by 3, and y equals 5. So my solution is negative 3, comma 5. Again, remember, we don't put that in that order because I found negative 3 first. This is a ordered pair of x, comma y. All right, and then finally, in this next problem, I have 4x minus 6y equals 10 and 2x minus 3y equals 5. And I am going to look at this and say, okay, well, let's get the x's to eliminate. I can make this the same by multiplying by negative 2. So I have 4x minus 6y equals 10. Negative 4x plus 6y equals negative 10. Okay, combine my like terms. That gives me 0, 0 equals 0. Okay, I have 0 equals 0. My variables are all gone, and it's a true statement. So my solution, there's infinitely many solutions. Last problem is considered a special case. What is the other special case? Remember, that's no solutions. And that would happen if, when we eliminated our variables, that we got a untrue statement. Okay, to get the same lines and infinitely many solutions, both variables need to cancel or be eliminated, and the numbers on the right side of the equal sign add to 0. To get parallel lines and no solutions, both variables need to eliminate, or cancel out, and the numbers on the right side of the equal sign is not 0. Okay, or basically, remember, if it's a true statement, then it's infinitely many solutions. And if it's a false statement, then it's parallel, no solutions. Okay? And so that's our third method of solving systems of equations by elimination. See ya.